Well, sadly, I lost some stuff at the end of the recording for this one, but I actually got a lot more than I thought. So, here you go. Okay. Um. Mm. Mm. I need to prepare. I am. What the fuck? Oh, you. Okay. So it kills the screen recording if you
I think somebody's looking.
Oh, Matilda? No?
No. Well, maybe she's stalking with someone. I thought she was.
But she was supposed to. Anyway, um, I need to fix something.
Oh, damn. I forgot. Oh, my. Never mind. I'll be. I'll be here for like 10 minutes.
No worries. I will try to make that an interesting 10 minutes.
Here's how you blow up the building.
What the fuck? Don't do that. Okay. Not how you blow up the building. No blowing up buildings. I promise it's worth it. It's so stupid, but it's so worth it. Okay. So, it's like that never happened. No one remembers that happening, right? No one remembers me unplugging anything. Oops. No one remembers it. Good. So hopefully this will work. And yay! Okay. The final log rust reading group. Please sign in with that link. But we have something a little special. We are dealing with Unsafe Rust, for a bit of it at least. This is Koro the Unsafe Rust Urchin. He's an alternative mascot. And also, oh god, that crop is awful. But it won't be awful in the recording, so haha. There's a feedback form. That's just a Google form. It's optional. I'll show it later as well. But if you have to go soon, then please feel free to take this. Or it'll also be posted on the Discord. But among other things, it asks for like feedback and if you're interested in continuing any of this virtually over the break. Just be honest if you can. I'd appreciate any input. So I'm going to eat a little more. And then so I'll show this again and post it like I said, so it's fine. So what are we gonna do today? This is very optimistic. We're probably only gonna do the unsafe and maybe the peaking. But I'm gonna take a break from the list because I get to, because I am absolute ruler of this little Rust reading group, and show some stuff that I think is interesting that's still Rust related about undefined behavior. So, who here has an idea of what undefined behavior is?
Like fuzzy definition or overall?
Any definition, like, I mean, programming related, but like anything you want to say.
Uh, behavior not defined by preprocessor of the program.
By preprocessor of the program. What do you mean by
In this case, I think it's the Rust compilator,
the compiler?
the compiler.
Okay.
Like, this is not in the standard of the language, so whatever the compiler does is like it could be anything.
These are good ideas, and I will address both of them because I don't think either of them are quite right, but that is to be expected because it's a weird topic. So I don't know what's going on first. What do I do? Oh, I need to. What? Oh, okay. So, your notion was something not defined by the compiler, basically. And your notion was something where the compiler could do anything.
Because it's not in the standard.
Because it's not in the standard, right? Something not defined by the standard. So, it's actually, this is kind of perfect. It's kind of a mix of both. So, undefined behavior is behavior not defined by the standard and that the compiler doesn't make any guarantees about. So, what is undefined behavior in general? Like, undefined behavior is a thing that could happen in a program. You could write a program and it compiles and then a thing can happen in it. Most of those things are defined behavior. Some of those things are undefined behavior. And when that happens, it has implications about what is allowed to actually happen in the program, right? When you write code that causes something undefined to happen, like indexing outside of an array, or dereferencing a null pointer, or dereferencing a pointer that's been freed, right? Those are all undefined behavior, and that is what was I saying? Yeah. And something will happen in your program, right? It's not like, in this situation, the compiler didn't prevent you from writing this, right? So the compiler let you write it, and you're running it, something will happen. Undefined behavior is specifically when we have no idea what will happen unless we run the code, but there's no guarantee. So I could write some code that invokes undefined behavior, and then tomorrow, when I compile it, and then it does something, and maybe I'm fine with that something that it does. And then tomorrow, I compile it again. Probably do have to compile it again to get this behavior, but I compile it again and it does something else, right? Maybe the version of the compiler changed, or maybe I changed something unrelated in my code, and that causes this to happen. So I will dedicate the first little bit of this to talking about that. So, examples of undefined behavior. And this is a concept beyond Rust, and in fact, Rust generally tries to prevent this from happening right at compile time, but you can still get it to happen with Unsafe. But examples of undefined behavior at a high level are, I guess, use after free. I'm going to say some. Use after free and index out of bounds. And can anyone think of any other examples?
In C, if you define a pointer to something but not initiate it, and then you
reading.
How you dereference it after.
So reading uninitialized memory.
Yeah.
Yes, that is undefined behavior. So that's like I did int x printf %d
I meant
x.
Okay, yeah. I think this is also undefined behavior.
Yeah, it is.
I meant if your int was a pointer.
Oh, okay, yeah. So also it's literally the same thing, but it's like int star x
Yeah,
equals.
I tried to dereference that pointer.
malloc size
Like,
of
whatever.
int, and then if I do this again, but I print.
Yeah. Oh, yeah. It's
Yeah, no. But I want to talk about this. I'll change it to p because that makes more sense. So this is also undefined behavior. Yeah, I'm talking about this simply because we're using pointers, but the problem isn't to use after free. Like it's not freed. It's just also uninitialized, right? But these are the same case, and I think it is interesting because in Rust. No, in Rust you can have uninitialized local variables. Like you could have the equivalent of this sort of thing in Rust as well. But you do it with unsafe. You introduce all of these issues with unsafe.
wait. So
Um,
is the compiler not gonna allow you to like not define the?
without unsafe,
Yeah,
you
like,
can't do
what-
this.
Like
Yeah.
what else can do?
Okay. Yeah. Let's good example. Uh, let me tell. Okay. Yes. Okay. So now everything's fine. Let's say I have let x, right? And I don't assign to it. What do you want to try to print it?
Yeah, I wanna see like, is it gonna give you like a message?
Type annotations needed. So right now it doesn't even know what x is,
Okay.
right? So let's make it an int.
Oh, this is it.
Rust is brilliant.
This is so nice.
It's so nice. However, you can always break this rule. I don't know off the top. Oh, I think I can do it like this. What if we did let x equal. So this is the first bit of unsafe. It's a little bit of weird unsafe. Let x equal maybe uninit new.
What?
Yes. So the whole point of that, like, the point is not I want to create an uninitialized value. The point is I want to create a value whose initialization is not checked, right? We don't actually want to write code that looks at uninitialized values. That's stupid. We want to write code where we decide whether it's okay, right? We want to circumvent the compiler. That's why we're doing this. Okay, so how does this work again? Oh my God. Okay, let's go to. I don't even know if I've shown this. If you have Rust installed and you run rustdoc dash no, what do you do? Rustdoc? No. Cargo doc dash help. Cargo help doc. Cargo. What does that do? Cargo doc dash help. This should work. I want to find the documentation for. It's rust up doc. Rust up doc. Okay. No, even better, even more directly. Rust up doc dash std. This opens the standard library documentation. And this is beautiful because it's actually local. So even if I didn't have internet, I could still be looking at the standard library documentation right now, which is beautiful. I don't know. I love it. Yeah.
I have C++ reference downloaded.
Well, yeah,
For the
but
same reason.
yes, but you don't even need to. Okay, so
This is very nice.
yeah.
It's like another year.
Yeah, you just get this for free if you install. Okay, std may be on a wrapper type to construct uninitialized instances of t. So this is exactly what we're trying to do. We're trying to create an uninitialized integer and then try to read from it. Compiler in general assumes that its property, yes, zero initializing a variable of. Oh, interesting. Yes, so references are guaranteed not to be null. So if you zero initialize one, that is actually immediate undefined behavior even before you dereference it. Rust, there's the double-edged sword of in Rust. Like in C++, there are lots of things that are undefined. But in Rust, because by and large the language is a lot nicer, and it has more guarantees, if you break those guarantees in your unsafe code, it's actually easier to break those guarantees because there are more of them, and as soon as you break it, you have undefined behavior. So it's kind of a disaster. The double-edged sword is unsafe Rust is more dangerous than C++. Because you have to uphold what unsafe means. I should have said this earlier. What unsafe means is the compiler was upholding a bunch of guarantees before. Now it's my job. So the better the safer and nicer the compiler is normally, the harder my job is when I'm writing unsafe. So because references cannot ever be null, if I make a null reference, that's immediate undefined behavior. Whereas in C++, pointers can be null. So if I made a null pointer, that's not immediate undefined behavior, right? There's this trait. There are other instances of that as well. And but I want to just screw around with this and then, but then show something more direct. And of course, this will be recorded. So if you are interested,
See you in the recording.
see you in the recording. Yeah, what? You have to go too? Okay. Well, I want to try to finish showing you this very quickly. This may be on a init thing. I can do. Maybe uninit.assumeInit. Yes. So instead of new, I call uninit. So this is get me some memory. I don't care what it is. And then literally just assume that it's initialized. And I have to do this in unsafe. Otherwise, it's a bug because I think assume init is unsafe. But uninit is not. I can create an uninit value, but I just can't access it without being unsafe. Okay, so now I've completely broken the rules. This is instant UB, but we can also try to print it. And I guess I don't actually remember how this works, but I think you do like this, and then, yeah, again, this will be, yeah, see ya.
This will be posted?
Yeah, it'll be recorded and everything. It is recorded. Yeah.
Yeah, thank you.
See ya. So were you following? I know I was going fast.
Yeah,
Okay, yeah. So if I call foo here, and then I run cargo, first let's cargo build to see, okay, so I messed something up. It doesn't know what x is. So even when we're trying to cause like all this crazy thing, it still needs to know what this is. So I'm just going to claim it's an integer. Now we're happy, right? It says the type i32 does not permit being left uninitialized. Integers must be initialized. I've never seen this message before, and it's really weird because it implies that some types can be left uninitialized, but I bet they can. That is such a Rust thing to do. I just don't know. Anyway. So now I think it'll compile, and let's test it. And it doesn't know what foo. Okay, wait. I need to. No, I don't want to qualify it. Let's just use superstar. So use everything in this file in this little module, so I can call foo. Test okay. Okay, interesting. I think this is a problem because we didn't see any output, and that's because by default Rust doesn't actually print the outputs of your tests unless they fail. And this is entirely so that it's like cleaner to look at your test results. Normally you don't care about what they're printing unless they were failing, right? But here I'm literally using this test in a completely backwards way just to try to get this code to run. So what I'm actually going to do is I'm just going to make this test fail. But then it should actually show us what this printed. You know, this will print something, right? Who knows? And we failed. It looks like we printed 1. I didn't set this to anything. So that's funny. I didn't actually plan out this whole thing, but I think this is cool enough, right? We printed 1. Let me make sure that that's, you know, if I print hello, 1, this is screwy, because actually this line invoked undefined behavior. It said, no, actually I think this line did. I think probably this, I don't know which line did it, but one of these lines did it, right? Either creating the integer, creating this actual x that is still undefined when we did assume init, or printing it, and therefore accessing it, caused undefined behavior. What that means is the compiler is allowed to produce code that does anything in this situation. It's not obvious why you'd want to do this, but I just latched onto it because it was a cool example. I will have a better example soon. But that means that by this point, definitely anything is allowed to happen. So according to the rules of Rust, there is no guarantee that our code will even print hello. It could do whatever the hell it wants because we caused undefined stuff to happen here. But this is what's tricky about it, because it's not like the compiler hates us. The compiler isn't going to try to do something we didn't want, so probably it's going to print hello. But if the compiler finds a way to make our code faster that doesn't involve printing hello, then it's not going to print hello. Like, this is entirely, the motivation for this is optimization. The motivation for undefined behavior is when you know what you're doing and you want to avoid all the checks, and you want the compiler to avoid all the checks, but still try to make things as fast as possible, then you are saying, I promise to uphold the rules. If I don't, compiler, you can do whatever you want. And this makes the compiler's job easier and makes things faster. I don't know if that, I'll have a more concrete example. But what happens here is we print a different number. Look at that. It did print 1, now it prints this. So I have no idea why. I don't know if it's looking in memory. I don't know if it's looking at a register. I don't know. But it did print hello, so I guess that's good. Anyway, better example of undefined behavior. I probably should have started with this, but this is from a very fancy book that Jacob actually posted in the Discord pretty early on, that I was like, I'm not covering that because it's too fancy. But this bit is not that fancy. This book is Rust Atomics and Locks. It's like concurrency. So I think have I talked about concurrency yet in Rust at all?
In one of the meetings?
Maybe?
I'm not
You don't know? Okay.
Maybe it was one of the ones that wasn't there.
Yeah, fair. Oops. So just briefly, concurrency is, what am I doing?
Actually,
Oh my
did you
God.
talk about it a little last week, maybe?
Maybe? I could have. Well, not last week, but
No,
yeah, last meeting. Yeah, maybe. Concurrency
I know it was
is
brought up, but
yeah.
I don't know if you went into it.
Right. I definitely mentioned it because I had the event on concurrency,
Yeah.
actually. But yeah, concurrency is, I didn't go into it, but concurrency just broadly is like you have 2 bits of code doing stuff at the same time, and this is really dangerous if they're able to modify stuff out from under each other, because then they can't rely on anything, right? And then it's like, who knows what happens first? And this is a giant problem that, in terms of potentially popular languages, Rust is basically the only one that I know of that attempts to really fix this. And it does so by using its type system to guarantee that if you don't use Unsafe, you don't have the problems that come with concurrency. So that's why this book is cool. It describes all the ways that you can use safe Rust and unsafe Rust to make sure that you can have, like, you can take advantage of multiple cores and run multiple things at once, but still do things correctly. And safe Rust is very helpful because by default, like I said, you can't have a lot of different errors that would happen. They're often called data races, where things are 2 threads, 2 parts of your program are racing with each other, right? One needs to happen first, but who knows what happens. Okay, so, but first, let's just, well, not first. Instead, let's just talk about undefined behavior. So I already sort of talked about undefined behavior. This is interesting. One of Rust's rules, it should really be one of Rust's many rules, I think, is that there may never be more than one mutable reference to an object. So I think I showed mutable references here, right? Like this is a mutable reference to the list. If I somehow wrote code, and it's not possible without Unsafe, but if I somehow wrote code even with Unsafe that even for a second created 2 mutable references to the same thing, to the same list in this case, right? That's undefined behavior. That's another case where Rust is actually stricter and trickier than C and C++, because in C and C++, there's nothing like ampermute. There's nothing like this that guarantees there's only one reference, right? So that's not a rule that you, well, there's something sort of like it, but there's nothing exactly like it. that's not a rule you have to uphold in C and C++, but in Rust you do. So thankfully, this sounds really bad, but thankfully in Unsafe we don't typically need to use these. You can do things with pointers instead, and those operate a lot more like C and C++. But I'll focus here on this little bit. Let's look at this code. Okay, so we have an array, and then we're indexing into that array here with the function getUnchecked, or method getUnchecked. Oops, getUnchecked. And that is different from if we were just indexing into it by default. So let's see. So what do you think? This is just a guess, and you're, of course, allowed to be wrong. What do you think is the difference between line 18 and line 19? So yeah, the labels are weird, but 18 and 19 here.
Is it 19 like not an unsafe or?
That's true. What's different about what it does?
Oh.
So I can explain this. I don't actually want to hover over this because that's kind of part of the point. But this is an unsafe function, which means you can only call it an unsafe. If I did this, and then even fix the syntax error, I still have an error here. Let's just make index a variable. For now, let's just make it 0, so we don't get that error. Okay, so we're not getting that error. We are still maybe. That's not an error, but whatever. Okay, now it's all fine. We're still getting an error here, and it's because call to unsafe function is unsafe and requires an unsafe function or block. So that's part of it, but that doesn't actually. What am I? Okay, that doesn't actually explain what's different about what they do.
Well, I don't exactly know what 19, or is it a?
Yeah, this is 19 now.
Right?
Yeah, sorry.
I don't exactly know what 19 does.
Okay, so what's 20 do? Okay.
Oh wait.
So.
Oh. I guess the index, no? Or?
Yeah, well, it indexes into the array. So it's going to try to look at element 0, right, of array A. So what is C going to be? If we ignore line 19, just.
Oh, it popped up. But.
Oh, did it? What?
Yeah,
what happened?
You hovered over it a little bit. It just popped up. Yeah.
Oh no, this is fine.
Oh,
that's but maybe I hovered over something else, but I don't know.
Oh, okay. Never mind.
It's fine.
Would it not just bring in the array back?
So no, so indexing into the array means getting one item from it. So like the array is 3 items, 3 things.
Yeah.
Indexing says get me the indexth, like index th.
But how does the index like choose the order of like?
So, sorry, what?
How does the index like choose the order of
right?
Which item?
So the arrays are in basically every language, arrays are ordered lists. Yeah. So it's just somewhere in memory you have space for 1, 2, 3, space for an integer, more space for an integer, and then more space for an integer. And what indexing does is and arrays are also 0 indexed in most languages. So that means that index 0, which happens to be what we're getting here, is the first thing. Index 1 would be 4, 5, 6. Index 2 would be 7, 8, 9. So C will end up being 1, 2, 3 because we are trying to get the 0th element of A. Does that make sense? Okay, yeah. I forget that you have less of a computer science background, so, but this is all good. It helps me teach too. Um, so yeah, so I could say, looking at this line, like knowing that A is an array, but not, let's pretend I don't know the value of index. Let's say, what does this line do? Well, I could say it gets the indexeth value in A, right? But that's actually not the full story. It does something before that. It also makes sure that index is less than 3. Because if index were 3, then I would be asking for the 0, 1, 2, third element in this. And there is no, like starting from 0, there is no third element, right? So that would be a problem. That would be undefined behavior. And I'll talk about why anything can happen there. Yeah, so that would be a problem. So what Rust does is, by default, when you're indexing to something, first it checks to make sure that you can access this. So if this were greater than 3, Rust would panic. We'd have an error, and it would blow up. I think I can... let me show that. So this will work fine. Well, let's not spoil it. Okay. Right, this will work fine. Except this is still failing. Let's... works fine, right? But if I tell it to access the third element, I claim that it will fail, and it fails. Oh, it doesn't like... no, that's just a warning. It could not compile. What? Oh, I didn't make this a test. But I don't actually know why it couldn't compile. Maybe I screwed something up. Couldn't compile it due to one previous error. A index. Oh my god. Okay, so in this case, Rust is actually very, very smart. And errors because it knows that it will panic. Because it sees, I didn't know that Rust would do this, but it sees 3 is too big, right? So this isn't going to work. And if I hover over this, it actually says like, no, it doesn't say? Huh. So my my editor is a lot less smart than the compiler. Let's see about restarting the language server to see if it... So I'm just restarting the bit of the code, the bit of my editor that like highlights things. Okay. So it still doesn't want to tell me something that the compiler can figure out. That's funny. Usually like you get the error message in both places, right? But anyway, so this sort of demonstrates what I was trying to demonstrate. Like if it had compiled, it could have compiled, but then it would have always blown up, right? Because there is no third item. What's important here, or what's important is that is a separate step. In the code that actually gets created, it is a separate thing that it has to do to check, is this less than 3, before it actually shows the item, before it fetches the item. So what indexing actually is, like just getting the item, is let's look in memory at the address of A. Oh. We have some array A, and it's just like in memory somewhere, and it starts an address and goes some distance, right? Yeah. Here we have 4 things in it. And then if I want to do A sub index, that means the compiler goes to address A, goes to the start of A, and then adds index to that and jumps that number of these boxes, these elements, down, and then picks whichever one. So if I did like, let's say this array has just, so that they're not the same as the indexes, that's why I picked those numbers. Let's say I do A sub 2. Then the compiler creates code that takes the address of A and then adds 2, and then gives me 11. And this is also how we end up with 0 indexing, or at least it's one justification, right? Because the address of A is the same as the address of the first element in A. So we actually call that the 0th element, because what this does is it adds this to A. So A sub 0, if we're 0 indexed, also adds 0 to A. It just gives you this first element. Does that make sense?
Yeah.
This 0th element. Okay. Anyway, so that's what the actual indexing does. But all of these things in Rust will do the check beforehand. The only difference between these two lines is that this one doesn't do the check. Get unchecked. And returns a reference to an element or subslice. Returns a reference. Interesting. What is the type of B here? It's a reference. Okay. So it does something different, right? Because C is, so I was wrong. C, there's actually another difference. C is just the integer. We copy the integer. But with this, B ends up being a reference to an integer, so a pointer to it. But let's make it the same. So if I dereference it now, I end up getting the actual integer. So now the only difference is we didn't check here. Hi.
Oh, hello. I like canceled my discussion session.
Oh.
So I'm back.
So we didn't get that far, but it's all good. So I'm still going. I mean, I think, yeah. Just basically what I just said is this line here is exactly the same as this line, except this line doesn't check to make sure index is less than the length of A.
Wait,
Right.
what happens if you like go out of the bounds? Like, is there a
Right.
runtime error? Or
If I go out of bounds with which expression, because it's very different.
the
With
safe one.
the safe one, it is a runtime error. Except actually in this case, the compiler is able to figure it out and says error in compilation. This operation will panic at runtime.
Because that array is like not dynamic.
I think it's because because the array is not dynamic and the index is a constant.
Yeah. Okay.
Yeah. If the array were dynamic, then it wouldn't be able to figure it out because it
Yeah,
wouldn't
and
know
the
how big it
index
is. Yeah,
as
yeah.
well.
And yeah. But anyway, I was surprised. I thought this would panic, but it fails to compile, which is great. But anyway, this code works fine, right? I mean, it doesn't work fine, but it compiles, and that's scary. This is going to read out of bounds, and I'm just going to print B here. Not like that. I'm going to println. I'm going to actually write Rust. And I did a similar thing. I created a test that just calls this. So this actually won't print anything if I run cargo test because, oh my god. Okay, so actually get unchecked is what? Okay, so I think because I'm testing it and because for some reason like it's not all the way optimized or something, it actually is such a misnomer. This is actually checking. But the important thing is that check is not guaranteed. If I ran, how to disable UB checks in Rust with get, I'm actually going to ask an AI because like that's the fastest way to get an answer these days. Bruh, there are, but I gotta panic. You dumbass. Debug versus release is not, if you want guaranteed no check, still UB if wrong. Okay, debug, if I'm using Miri, I'm not using Miri, I'm not using the I don't want checked. I don't want checked. But I gotta panic. Okay. You are so wrong. I'm hitting a debug assert. Wait, hang on. Oh no. I've lost my mind. How did I even type those characters? Okay. It's riveting, I know. I'll get back to... I think I'll only cover the unsafe here. Shut up, ChatGPT. Okay. I mean, currently indeed... I use it... Okay. Can I cargo test dash release, or is that not a thing? That's a thing! What? Oh, I didn't... Okay, so I don't get... I get an error, but that's because I panic. Did I panic? No, I didn't panic. What? Why did you fail? Now we're trapping. I don't know. Okay, I'm not going to be able to reproduce the behavior that I actually want. I wanted it to print whatever the hell. I was able to get this to print whatever the hell. So what do you think this is going to print when I cause it to actually... Oh wait, maybe the problem is I'm invoking undefined behavior here. This is also the problem with undefined behavior. There's no way to... Okay, no, it wasn't that. There's no way to really know what's going on. So what I showed him earlier, just so you don't have to watch the video, I guess, is that if I call foo and then I panic, panicking is just so that it'll print things. It doesn't print things from succeeding tests. If I call foo and this does what I was showing you, right? What do you think will happen? Yeah. So this, yeah.
Okay, so you're just like unsafe, not initializing.
Yes, and then I'm reading it and I'm printing it. And then I print hello.
I mean, if the program has access to the memory, it would just be like a random value.
You are maybe correct. Why did it? Oh yeah, I panicked, but yep.
Yeah, it just.
Yep. Anyway, so let's get back to the example. I don't think I'm going to be able to reproduce this well, but that's because Rust is trying to save me even when I'm using unsafe. Okay. This is the actual point. The getUnchecked method gives us an element of the slice given its index just like the normal thing, but it allows the compiler to assume the index is always within bounds without any checks. This is important that it's like very specifically this, because it's not just that it's just going to do the access. It's also allowed to assume that this is true for any other optimization purposes. So because A is of length 3, the compiler may assume that index is less than 3, and because index is an integer, actually, what is it? It's a... I should hover over here. It's a usize. So this means it's a 8-byte integer because we're on...
And unsigned.
What?
Unsigned.
And it's unsigned, yes. Interesting. Yeah, you here means unsigned, and size just means it's 8 bytes because for us because we're on 64-bit.
I'm assuming it's like same as size underscore t.
It is, yes. At least it's very close. I think it is, but so because it's an integer, because it knows that index is less than 3, because we promised, because we're indexing into something that's only 3 long, it actually knows a lot. It knows that index is 0, 1, or 2. So it's going to assume that. So if we write this code, which is funny, look at this funny little code. We match on index before we call a.getUnchecked index, right? And if index was 0, we call x. If index was 1, we call y. If index was anything else, we call z of index. And these are functions we haven't defined in this code, but it's defined somewhere else, right? a really weird thing can happen. If index is actually 5, then what should happen, what we, the programmer, think should happen, is that we go here, right? And we call z of 5, right? And then who knows what happens here, but like, I don't know, the undefined behavior happens later, right? When we try to use 5 and index into A, and it gets us some random value, right? Beyond the edge of A. But that's not necessarily what happens. The compiler can actually turn this underscore into 2 because it knows that this must be within bounds. And if it then figures out, oh, this must always be 2, and it's faster if I just call z of 2, we can have index be 2, but then have this run, you can run this code with index being 5, and then it's actually going to run z of 2. Because it assumes that the only other case other than index being 0 or 1 is that index is 2. Because otherwise, we would cause undefined behavior down here. So even though we only cause the undefined behavior down here, the compiler is reasoning about our whole function. So it figures out, oh, it can never be like you promised.
Wait, this is horrible.
It is. This is why, but this is not a problem unique to Rust. This is a problem with undefined behavior. Undefined behavior can travel back in time in these sorts of ways. If you make it so that undefined behavior will happen, from the moment you've made it so that it will happen, from the moment that you set index equal to something that isn't 0, 1, or 2,
C doesn't have this problem.
C has this problem.
Like in what way?
You could, if you turn the switch into a match, and C has this problem.
Like if you
Turn the match into a switch, it has this problem.
like what would be like optimized away?
The point is it might be.
But if you like set optimization level to like 0 or 1.
Then it won't be.
Okay, so.
But that's a conversation you have with your compiler. That's according to the standard.
Rust has optimization levels.
Yes.
Okay. So.
According to the standard, though, this is undefined in. This would be like the equivalent program is undefined in C, and you don't even have to do any unsafe get unchecked. You can just do a normal index in C. Like the compiler could, the C compiler is just about as, Clang at least, and GCC too, but in different ways, just about as smart as the Rust compiler. If the Rust compiler would break this code, and I'm not sure it would, but if it could, then the C compiler would break the same sort of thing. So yeah, this isn't to totally scare you away, but it's horrible, right? But I think this is my favorite example of undefined behavior. Or simple example of it, because this sort of thing can travel, this sort of problem can travel back in time. This works for any kind of undefined behavior, not just indexing out of bounds, right? So if we had a situation where a pointer, I think there was some C code. I'm not going to get to anything else in this meeting, so I'm just going to look, no, Linux, there was some Linux code